So I already did a video on Friday. I haven't uploaded it to Edmodo. It is on YouTube already. It's on the first part of this test that we're having tomorrow. We're going to move on to the second part. This is video number 2. On this video, we're going to be solving equations, logarithmic equations. So on number 13 here, we have log base 3 of something equals 5. So you want to get x by itself, but x is inside the parentheses of this logarithm base 3. So you don't want the x with all of this stuff around it. You just want x by itself on one side of the equal sign. Let's get rid of this log base 3 by taking the entire left side of the equation and raising it to become the power of base 3. And what you do to one side, we do to the other side. I want to take this entire side, the number 5, and raise it to be the power of base 3 as well. So the equal sign is no longer up here. It's right here between the 3's. What I have here is 3 to this power equals 3 to that power. So when you do 3 to the power of log base 3, we know that those are inverses of each other. That eliminates, and the 4x minus 17 comes down as a regular 4x minus 17. The equal sign is still there. And 3 to the 5th, we could actually do that with the calculator. What's that? Anybody have a calculator? 3 times 3, what was that? 243. Thank you very much. So 3 to the 5th is 243, and there's your equation. That's how we get rid of logarithms, by raising the entire equation to become exponents of the base of your choice, which would have to be the base that was on your logarithm. Raise both sides of the equation and become powers of that same base 3. Anyway, let's continue solving here. We're going to add 17. We're going to get 4x equals 260. Final step would be to divide by 4, divide by 4. Final answer is 65. There we go. So I like those because logarithms are not on both sides. Oh yeah, one more final detail that you should do with every log problem. Once you get a solution, just make sure that that answer will not end up as a negative inside the logarithm. Because if you end up with a negative in here, 4 times 65, that's a huge positive number. I know taking away 17 is not going to make it negative. But if for some reason like my answer was like 2, if I plug in 2, I'd end up with a negative. That means that would be an extraneous solution. I'd actually write no solution instead of my answer x equals 2. Again, just make a quick check and make sure you don't end up with a negative inside the logarithm. You can't do logs of negative values. So on number 14, it's even easier because you get rid of those logs by raising both sides of the equation to become powers. This whole thing is going to become the power of base what? 9. And this whole thing over here is going to become the power of base 9 as well. That way, these guys eliminate. Your new equation becomes 3 minus x equals 5x minus 15. And then we just solve by getting x's to one side, plus x. We end up with 3 equals 6x minus 15. Then get rid of that minus 15 on the right side, plus 15. We're going to end up with 18 equals 6x, which means that your final answer is going to be x equals 3. Because you'd have to divide both sides by 16, and you get x equals 3. Now, is that the answer that I want to write down on my answer column? Why not? That's exactly right. If I take that 3 and do a quick check, first of all, 3 right here, 3 minus 3 is 0. Just right there, you cannot do the log of 0. It doesn't matter what kind of log it is, base 9, base 10, natural log, doesn't matter. You can't do log base 0. Okay? So if you do that on your calculator, if you do a check, log base 9 of 0, it's going to say error because you cannot end up with a 0 in here. So we know that this is an extraneous solution, so we say that our final answer is no solution. That's what you're going to write on your answer column, or the no solution symbol. 15 and 16, those are actually from the previous section. Let's say you're thinking, I want to get this exponent down to be a regular x. I want to apply a log base 8. Well, if you apply log base 8, it'll get rid of the 8, but over here it won't. right? So whenever you have different bases, let's try to get the same base. So 8 and 16, what could I change both of those to? Like 8 squared is 64, not 16. So yeah, we're going to have to change them both to become base 2. You can't even change them to base 4. That doesn't work either, because 4 squared is not 8. So anyways, let's change both of those numbers to become 2 to the third and also 2 to the fourth. And of course, we have the power of 2x minus 4 on the first one, the equal sign here, power of x minus 5 on the second one. So now that we have the same base on both sides, technically the explanation is that you could apply a log base 2 on both sides. That way they eliminate. But don't forget that a power to a power, you multiply. So 3 times 2x, that's 6x. 3 times negative 4 is negative 12. Equal sign comes down. 4 times x is 4x. 4 times negative 5 is negative 20. And the reason why I just wrote down this as my equation is because we know that log base 2 of 2 eliminates, and we know that log base 2 of 2 eliminates. So here's my new simple algebra 1 equation that I need to solve. So solving this, I want to subtract 4x, subtract 4x. I have a new equation that reads 2x minus 12 equals negative 20. And then we add 12, we end up with 2x equaling negative 8. So my final answer will be what? X equals negative 4. Thank you. Is there a need to plug this in to see if I end up with 0 or negative? No, because it's not a logarithm problem. It's not a logarithm equation. It's just an exponent equation. I mean, you could plug it in to double check that it works, but how about this guy? What do I do here to solve this equation?
You have to change the 1/4 to 1/4 to the third power.
Okay, so the 64, it is 4 to the third power. That's good, recognizing that. And this is already a 4. So we would like both of these bases to actually look like 4 to a certain power. So if I take this 4 and move it up, that's really going to become 4 to the negative 1 power. That's the same thing as 1/4. I hope everybody understands that. And of course, that first one has the power negative 4x plus 2. And then you have your equal sign. And then over here, the 64, we're going to rewrite that as 4 to the third power. Okay? And of course, that one has the power of x minus 5. Now that we have the same base, we're going to be able to eliminate those bases technically by applying log base 4. But before that, let's distribute negative 1, power to a power, you multiply. Negative 1 times negative 4x is positive 4x. Negative 1 times positive 2 is negative 2. 3 times x, that's 3x. 3 times negative 5, that's negative 15. And there's our new equation. Why? Because when I apply a log base 4, that will eliminate. When I apply a log base 4, that one will eliminate. So you end up with that simple blue algebra 1 equation right there. Let's solve it. We're going to subtract 3x on both sides. We end up with 1x minus 2 equals negative 15, which means that our final answer is going to be, after adding 2 to both sides, x equals negative 13. There's our answer for number 16. So let's end this video here, and we'll start another video on solving logarithmic inequalities. Right? Solving logarithmic equations are pretty easy. Whenever you have a log base anything, like number 13, log base 3, you raise that to be the power of base 3. Over here we had log base 9, so you raise those to be the powers of base 9, and you solve your equation. The inequalities, those are a little bit more fun. We'll check those out in the next video.